it's squishy, and I can squeeze it flat a little bit, and it bounces really well. Right? It makes a very satisfying sound when it bounces. And just as an experiment, I hold it out at arm's length, like this, and we let it drop. It bounces like about that high, right? It bounces pretty well. So let's take this racquetball, and let's see what happens. Let's say we were to make it negative 300 degrees. Put it in our liquid nitrogen, hold it in there. And it will get cold, and it will get more solid. You'll notice with the changes in states of matter from gas to liquid to solid, across that scale, we're getting colder, and we're getting more solid, right? Steam is a gas, it floats around. It's also very hot when it comes off of that hot water, but water can get a lot colder than steam can, and it tends to hold together a lot more. Until you get down to the temperature where that water freezes solid into an ice cube, and that ice cube becomes much more solid than just water. It retains its shape. And as it gets colder and colder, it becomes more and more solid until it gets very, very brittle. At the temperature of our liquid nitrogen, our racquetball is going to do something kind of similar. If I pull this out here, I want you guys to listen very closely and hear what it sounds like. Just when I bounce it on my table, listen to this. Right? It doesn't sound very rubbery, does it? It's out of the same material, but it's gotten so cold that it doesn't really behave the way you'd expect it to. Let's try that same experiment we did earlier. I take this very cold racquetball and I hold it out at arm's length and we drop it. Right? It's not very bouncy, is it? Thank you. So, even just holding it in my hands, right? I can't squish it. It feels very, very solid. It's like a rock or a marble or something that is not made out of rubber, right? So we'll let that sit off to the side. We might check on it later on once it warms up a little bit and see how it behaves. What I'm going to do right now is I'm going to take some more of my liquid nitrogen. I have this thermos here. And I'm going to take a look at some of that on its own. I'm going to pour it into this flask here. So we're going to add a little bit to there. Try not to spill it. Fill it up a little more. How about there? Alright. So we've got that. And this flask has two openings. It has this main one on the top where I pour that in. And it has this little vent coming off the side of it. You can see there. So what I can do is if I take a stopper and I seal the top of it, you guys can see all that steam is now being forced out through this side. So as a liquid boils into a gas, it takes up a lot more space, right? It's becoming less solid, it spreads out, it floats around. So we produce all this gas that's being forced out through here, because it can't all fit in the container. So what I've just done is I have built myself a portable handheld air conditioner. And I'll bring it around, you guys up front, let me stick your hand out, and feel the air coming off of there. You gonna feel it? Right? It's nice and cold. But it's not negative 300 degrees, is it? Right? Nobody's freezing their fingers off like that ice cream, right? Make my way on down. Right? So nitrogen warms up pretty quickly. It's not hold on to its heat very well. So by the time it gets to you, it's still pretty cold, but it's not dangerous, is it? Right? You feel the air coming off of there? You can feel it? Is that cold? Yeah, is that pretty cold? Right, so we have this whole container, the nitrogen inside of there is warming up, it's boiling, it's taking up more space. So let me ask you this question. If I had this container, there's pressure being let out through this vent here, what is going to happen? If I take my finger and I stick it over that opening like that.
Uh-oh.
It might explode. Is this a bad idea? Maybe. Well, we already started, so we got to see it through.
Oh. Popped its cork.
Eventually, as that pressure builds up, it's got to break through somewhere. So it might explode if the glass has a crack that I failed to notice before we started. And then it might explode. But a much weaker point in the container is this cap. Okay, just put on there, just kind of squeeze into space. It's not part of the container. So it will pop the lid into the air. Try it again. I already started. It's on there a little bit more tight. We'll see if you can get it to go a little higher. You got that for me? Take that back. Ooh, careful, guys. Yeah. You do one more? Yeah? Okay. On there, I'll come over here. Now it's really hard for me to control where it goes, so be ready if you see it coming towards you. Like the last time, be ready to either catch it, or duck, or throw your friend in front of you, or whatever you gotta do. Alright, here we go. Ready? Yeah. 3, 2, 1. One. Give it a second. Hang on. This is gonna be good. It's on there pretty good and tight. It's got a lot of pressure to go. It's getting very, very cold. Yeah, okay, here we go. In 3, 2, 1. Come on. I'll help it out a little bit. Give it a little bit.
Oh my
Hey, get some height on it. Hey, take it easy, guys. Take it easy. All right. Okay. All right. So that was pretty good. That's about as good as I think we're gonna get. That's got pretty high. Okay. One of my favorite things about working with liquid nitrogen, though, is it's real easy to clean up when I'm done with it. Right? Right? If I pour it out on the floor, is my floor wet there? No, right? Remember, keep your hands outside of there, guys. We'll make sure you guys